All right, today we are going to cover some more compound probabilities, and we'll look at some more Venn diagram stuff. So, here we go. Start right out with a Venn diagram problem. Oh, no, never mind. We'll start out with a little review. So is this compound event a mutually exclusive event, or is it an inclusive event? You have a deck of 52 cards. Explain why the events choosing a club and a heart are mutually exclusive. So what does that term mean again? Can you be one outcome and be both, right? So is it possible to be a heart and a club? No, so you have to be either heart or a club, right? So it can't be both. So can't be both. Okay. What is the probability of choosing a club or a heart? Well, if you have two compound events happening and there is no overlap and they are mutually exclusive, then you can just add the probability of a heart plus the probability of a club, and you're done deal. You don't have to subtract out any of the intersections. So probability of a heart is a half, probability of a club is a half, and so a half plus a half is, or I'm sorry, that should have been a fourth. A fourth, and a fourth plus a fourth is a half. So, and that, that should make hopefully common sense to you. Is what's the probability of choosing a club or a heart? Would be there's half of the deck. Okay. If you're picking a number 1 through 9 written on cards in a bag, so like let's say there's 1 through 9, so excluding 0, so 9 possibilities. Choosing a multiple of 3 or an even number. Is this mutually exclusive or inclusive? Mutually exclusive or inclusive? Can they be both? It can be both, right? So choosing a multiple of 3 or an even, let's list them all out. Let's list all the possibilities. Choosing a multiple of 3, that would be 3, 6, 9. Choosing an even number would be 2, 4, 6, 8. All right, are there any that are both? 6. So because 6 is in both of these, they are not mutually exclusive. So they are inclusive of that overlap. So now when we calculate our probabilities, we have to be a little bit careful here. We have to calculate the probability of multiple of 3 plus the probability of an even minus the probability of both multiple of 3 and even. So got to be a little bit careful there now. Probability of a multiple of 3 is going to be 3 out of 9. Probability of an even number is 4 out of 9. But we have to subtract because they both have 6. So we have to subtract 1/9. So the final probability there is 6/9 or 2/3. Now, I know that maybe some of you are thinking, God, well, that just seemed more complicated than it needs to be. Well, yeah, I mean, if you wrote out all the numbers like we did into a small enough sample or a small enough event, then yeah, you could just look at that and go, okay, there's 6 different possibilities. If you drew a picture like we did last week, we drew a picture, right, and you just make a little Venn diagram of the deal, then you can just go that route. Multiple of 3, even. Which one's both? 6. So 6 goes in the middle. Over here then would be 3 and 9. Over here would be 2, 4, 8. And you can see right there, there's our total. Wait, I'm missing one. Oh, no, I'm not. So you can see your total there is 6. So anyway, multiple ways of attacking those types of problems. Attacking them. Choosing a multiple of 4 or an even number. Same concept here, right? Multiple of 4 or an even number. What do you like better, drawing a picture? I think pictures are good. Multiple of 4 or an even. Multiple of 4, even. How many multiples of 4 are even? All of them. Okay, so then we're going to put all of them in there. So we got 4 and 8 there, and then all the even numbers, 2, we got already 4 already, so then we got 6, then we got 8. So 2, 4, 6, 8, 4 and 8 are overlap, so that means there's a total of 4 out of the 9 are either a multiple of 4 or even. So again, that is an inclusive situation. Why is it inclusive? Because there is an overlap. That's a weird one though, because there's no multiples of 4 that aren't even. Okay, so we're going to continue on with working with these Venn diagrams. Here's a little bit more of a complicated problem. So let's go ahead and read through this and fill out the rest of the Venn diagram. They already started it for us. So of the 1,560 students surveyed, 840 were seniors and 630 read a daily paper. The rest of the students were juniors. Only 215 of the paper readers were juniors. What's the probability a student was a senior or read a daily paper? All right, well, 215 were paper readers but not seniors. And it said there was 630 that read a daily paper, so that means the green part must be the remaining 425. You agree with that? Because it says 630 read a daily paper, and the oval that reads a daily paper is the yellow and the green part. So those together should add up to 630. Okay, and then same kind of concept here with the seniors. 840 were seniors, while 425 read a paper, and so the other 415 must not. And then that does not add up to the total 1,560. So if you add all of these together, which would satisfy the condition, they're asking us to find the probability. What's the probability that a student was a senior or read a daily paper? So that's going to be all of this, right? That's everything inside of there for or. And so either or would be all of those numbers put together. So 400, 400, and 200 is 1,000, and 15, 25, and 15 is 55. So that would be 1,055 out of the total 1,560 were seniors or read a paper. Right? So that means there's another 405, or no, sorry, 505 that are neither. So those guys would be out here. So now everything adds up to the total 1,560. Okay. The next page walks through, I think, yeah. The next page walks through the math behind, if you didn't write the Venn diagram out and you just added them, you would have to subtract the overlap. And so you could do it either way. I think if you have the picture, it's easier to just see the picture and see the 1,055 represented in all of the, 3 areas where it would be there, there, and there put together. So if you have the picture and it says or, you can just add everything up in the Venn diagram, including the intersection. If it doesn't, and you don't make the diagram, then you'd have to look and go, all right, well, I got the 840 plus the 630, and then I have to subtract the middle part out so that I don't double count those. But like I said, if you have the Venn diagram, it makes it a lot, I think, easier. Okay. All right. It's the 2 days after daylight savings, so students are looking a little lethargic today. And to top that off, it was a big rock and roll revival weekend, so everyone was out rocking and reviving rock and roll because rock and roll needs reviving, doesn't it? 160 beauty spa customers. 96 had hairstyle done. 61 had a manicure. Okay. So I think we're going to go with, that doesn't look good. Hairstyle. Going to get your hair done. Going to get my nails done. So we got a hairstyle or a mani. And 28 customers only had a mani. What's the probability a customer had a hairstyle or a manicure? All right, well, let's just stop and take a minute and think about what value goes where. $160 beauty spa customers. That means the whole, everything in the rectangle has to add up to 160. So that's inside the ovals and outside the ovals, but inside the rectangle. So everything's 160. There's one number that's like the best place to start. 28? 28. I like 28 because it gives us one specific section, and that's the people who only had manicures, which is right there. And then we can start subtracting from other values to get the other regions. So if 28 only had a manicure and 61 total had manicures, then that means there's 33 that had both, because now those add up to the 61. And then same thing with the hairstylers. There's 96 people got their hair styled. Will you style my hair? So that would be what? 63? Does 63 plus 33 add up to the total 96? You bet. So now, but those all don't add up to 160, so some people just went and bought shampoo there. 36. So if you add them all up, and that's what we want to find to calculate the probability of hairstyle or manicure is going to be the sum of that, and that, which is what, 96 plus 28, which is 124. So 124 out of 160 have a hairstyle or a manicure. Some students get confused with the word or, and they feel like you can't include the middle part. So if it's or, do the 33 people, does that satisfy or? They had hairstyle or a manicure? It does. But some people, it happens every time I teach this, some people get confused and they think it just has to be or means it's either one or the other, not both. But both does satisfy or. So that's why you add all of them together like that. So 33 does count when you're talking about or. Okay, let's try another one. See if you guys can get this one. I'll give you a 2-minute head start. Okay. Okay, so where are we at here? Brown hair and male. So we'll go male, brown hair. I think the number to start with was 100. Of those with brown hair, 108 were female, so that's this region. And then there was 368 brown hair, so that means 260 were male. Those add up to 368, right? And then of 570 people, or no, 365 for male, so that means there's another 105 that were not brown hair. Any objections? Questions? Okay. What part is it regarding? Here, I'm going to pause it. So of the 570, then this right here, this, and this, if you add all those together, what do you get? 473. So 473 out of the 570 were either male or had brown hair. So male or brown hair. So then the rest is going to be what, 97? So that number is accounted for on the outside of the ovals. Male without brown hair. So you find the overlap or the, like brown hair only, or like not, female brown hair. So you either find the overlap or you find the like male not brown hair part, and then you do subtraction of all of them. Okay. Here's a little different scenario. So now we're given, this one's a little weird, but the male, it's male and an English teacher or male and over 6 foot tall. So I think there's no females in this whole set, the whole rectangle. This is just all the male teachers. So all the male teachers would be all male English teachers, right? That's going to be 1. You would shade in, what numbers would you shade, or what numbers would be represented by that would be 1 and 2. 3 is not, because 3 are not teachers. And 4 is not, because 4 are not teachers or 6 foot tall. Because right here the whole thing is male. Everyone's male. No, 4 would be males that are not English teachers nor 6 foot tall. Yeah. Okay. So males over 6 feet tall. Which one would we color in for that? 3 and 2. 2 and 3. Males who are over 6 feet tall and who teach English. That's just 2. Males who either teach English or are over 6 feet tall, but not both. 1 and 3. Males who are not English teachers. 3 and 4. Males who are neither over 6 feet tall nor English teachers. That's just the 4 on the outside. Males who are not both an English teacher and over 6 feet tall. This one takes maybe a reread. Males who are not both an English teacher and 6 feet tall. So not both an English teacher and 6 feet tall is that one, right? So 1, 3, and 4. Who are not both an English teacher and over 6 feet tall. How about that? So if they're not both an English teacher and 6 feet tall, that's everything except for this. So that, let's call that 1, 3, and 4. That's good with that. Okay. Males over 6 feet tall who are not English teachers. That's just 3, I believe. Yeah. Because they are over 6 feet tall, but they're not English teachers. That's just right. Yeah. These people right here are not over 6 feet tall, so they don't meet the criteria. All right, so Venn diagrams, a little different way about asking about them. Okay, the way we'll ask you on the quiz will be like this. So we have some questions, or Venn diagram to fill out. And so let's think about this one here. All right. 31 are allergic to dairy, animal fur, and pollen. What section is that? Dairy, animal fur, and pollen. That would be right here, all the overlaps, right? 29 are allergic only to pollen. That's going to be out here. 12 are allergic to dairy products only. Out there. 40 are allergic to dairy products and pollen. Here we go. 40 are allergic to dairy products and pollen. The dairy products and pollen overlap is right there. So if that needs to total 40, then we need 9 more right here, correct? Okay. Okay. 68 are allergic to dairy products. So dairy products, that's everyone in this circle. That needs to add up to 68. Right now it adds up to 52. So we need a more. We need 16 more. Okay. What's the next one say? I can't read and erase this circle at the same time. Okay, now I can. 93 are allergic to pollen. 93 allergic to pollen. That's going to be everyone in the pollen circle. So that's everyone in there. So everyone in there needs to add up to 93. Right now they only add up to 69. So another how many gets us to 93 would be 24. Okay, and then 91 are allergic to animal fur. So same question, except for now animal fur is the bottom circle. I'm going to stop doing the circle thing. So what does that add up to? So 20 more, I think. Is it 20 more? There you go. So 20 more down here. So now we have some follow-up probability questions. How many of the patients are allergic to only animal fur? 20. What percent of the pages? We'll get to them, I don't know, because I'm moving. How many get up in this? 4, 2, 3. What percent of the patients are allergic to only animal fur? All right, well, that's 20. How many patients are there total? Oh, cripes, we got to add them all together. I think I remember from the previous class, 141. All right, 20 out of 141. If we do that division as a percentage, it's 14.2%. How many of the patients are allergic to only pollen? 29. 29 of those 29. Oh, wait. How many of the patients are allergic to animal fur and pollen, but not dairy? So animal fur and pollen, but not dairy. Animal fur and pollen, but not dairy. That's this one right here, isn't it? Animal fur and pollen, but not dairy. No, that would be or. Animal for animal fur or pollen. Animal fur, oh my God, I can't say it. Animal fur or pollen would be like all of this, right? You know how we'd add them all together? But it says animal fur and pollen. So since it says animal fur and pollen, now animal fur and pollen is just this, the overlap between animal fur and pollen. But then you can't include the dairy because it says not to. So it says, how many of the patients are allergic to animal fur and pollen, but not dairy? So you get rid of that little part right there, and we're just talking about 24. Kaylee? Yeah, I just added them all up. Yeah, every single one. Okay, So get rid of that, and get rid of that, and get rid of that. All right, what else? One more question, maybe? Last one? How many of the, whoa, almost dropped my calculator. How many of the patients are allergic to 2 or more of the pollutants? So 2 or more. Yeah, it's got to be these, right? Let's use my highlighter. 2 or more, is that 2 or more? Yep, is that 2 or more? Is that 2 or more? And that, I think that's it, right? Yeah, so that's 80. All right, 80. I think it just said how many. Yep, not a. So you got to be careful when it says like what percent or what probability, or if it just says how many. Be careful what it's asking. Sometimes people give me a probability, but it just says how many. Okay, I believe that's the last page, right? We got a little assignment, ACT tomorrow. So happy March 11th, 3/11 day.